and gentlemen, we are starting chapter 2. So this is an intro to chapter 2. Everything about chapter 2 has to do with linear equations, basically straight lines, and how we graph them, how we write them in equations, all kinds of things. So in the future, we're going to look at tables, right? We're going to see when you look at the numbers in a table, you graph that on an x and y axis, you get a straight line, and then we're also going to talk about how you turn that into an equation. Now, the first equation we're going to learn is a slope-intercept form. Now, this is one you probably have learned before. It is y equals mx plus b, okay? So, what does all this mean? So basically, in your table, when you have a table, you have an x and a y. When you plug in x, these numbers will change it and it'll give you a y. We call this like an input and an output relationship. You plug in x, you get y. But how do you change x? Well, you change it with multiplying the slope. This is slope, m. B is your initial starting point. We call it the y-intercept. Or it's your initial number when you start at 0. When you start at 0, you get the b. You get b. So these are the words slope, y-intercept. That's where we come up with the name slope-intercept form. Y equals mx plus b. Now slope is important because the slope has its own formula. Because a slope is basically when you're comparing 2 points. So if there's a line, right, you're going to need 2 points on that line. And what we're comparing is, hey, how much does that line increase vertically and how much does it move horizontally? So we call this the change in y. That's a symbol for representing the change in y and the change in x. So you have to find the slope and you write that as a fraction. You have the change in y over the change in x. Some people call it the rise and the run. And that'll give you slope. So there's a separate formula for just finding the slope of a line. And that basically the slope is how much is that line increasing, because you can also have a line that's decreasing. So in this chapter, you're not going to hear me use rise and run a lot. I'm going to use the change in y over the change in x because we don't always have a rise. That's not always the correct term to use. So the change in y over the change in x is what you're going to hear me use a lot of the time. All right. So let's get to problem number 1, graphing them. So here's 2 examples of problems they want us to graph. And remember, we're using slope-intercept form. So we have to identify our starting point, which is our b, and our slope. So our b and our slope. You want to identify those things because these are written in slope-intercept form. All right. Now, when you graph, you want to start with b. So here, the b for the mx plus b is -5. 1, 2, 3, 4, 5 down here. All right. Now, my slope is not x. Remember, x is not your slope. That's the number that you plug in. Your slope is the number next to it, 3. So when you have a number like this, remember what I told you earlier, right? Y equals mx plus b. That's what we're looking at, these equations as slope-intercept form. The slope, the m, is written as the change in y over the change in x. But I don't have 2 numbers, I only have the number 3. So what do I do in these cases? Well, you have to write this number as a fraction. So how do you write a whole number as a fraction? Well, you put a 1 underneath it. And now you've turned it into a fraction. You have your rise and your run, or as I like to call it, the change in y and the change in x. So what that means is, from your starting point, from the y-intercept, you're going to go up 3 spaces. 1, 2, 3. Up 3. right here. And then to the right, you're going to move one space. Up 3 over 1. Your change in y and your change in x. And then you can draw your line. Now when you draw your line, you make sure you put arrows at the end because this line goes on forever in both directions. Okay? Now if you have trouble drawing a straight line and you don't have a ruler, what you can do is do the slope multiple times. So here's what I mean. If my slope is up 3 over 1, then I can keep counting by that amount. Up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. And your points will line up in a straight pattern. If you keep counting up 3 over 1, up 3 over 1, up 3 over 1, if you keep counting that way, you'll get a straight line. It'll make it easier to draw a straight line if you don't have a ruler. So that's an option for you. Okay, over here. Here my starting point isn't a negative. Right here was a -5. Here it's a +4. So I'm going to go 1, 2, 3, 4. This is my y-intercept. This is my initial value, my starting point. My slope is already a fraction, which is good news for me. So my slope is -2, 3. Now, when you have a fraction and a negative sign, okay, actually the fraction is fine. It's the negative sign that can be confusing. What I like to do is I like to put the negative with the 2. So I like to call this a -2 over 3. -2 over 3. You can put the negative on the bottom. I just don't recommend it. I like making the change of y, the top number, I like making that one negative. That means that this is actually a positive number. I know it's kind of weird, but the reason is you can't have both of them be negative. Because if these both are negative, you have a negative over a negative. And guess what happens when you have a negative over a negative? You have a positive. So only the top number is negative, the bottom one will be positive. So what do? Well, that means you're going to go down 3. 1, 2, 3. 1, 2, 3. Yeah, down 3. I'm sorry, no, I messed up. I apologize. Down 2. My mistake. You see, I'm already messing up. Down 2. The 2 is negative. The 3 is positive. Now, positive for x is to the right. So this way. -2 over 3. Okay? So, and if I want to do it again, down 2. 1, 2, 3. And then I just take those 3 points and I draw a straight line. And it helps keep it straight. Okay? So you repeat the slope, down 2 over 3, down 2 over 3, and that is the slope, and that's the line. That's how you do it. Okay? So that is how you graph in slope-intercept form. Next, what if they already have a graph? What if they have a graph and they want you to write an equation for that graph? Okay? Well, remember, we're going to use the equation for slope-intercept form. We're going to use y equals mx plus b. Okay? So, we're actually going to start with the b, the y-intercept. Now, the y-intercept is the value on the y-axis. So this line, not the x-axis. Don't look at this one. This one doesn't matter. You start on the y-axis. You're looking for where does this line cross the y-axis. And it's right there. That is b. And what number is that? -1. Okay, so far you have this. mx minus 1. Some people do like to write it like this, plus -1, but honestly, that looks kind of weird to me. I would just write it like this. I would just write it like that instead. Okay, now we got to find slope. Now to find slope, you need 2 points. Now you see there's a bunch of points on a line. You have to pick 2 of them. Now, I am not going to pick these points. Even though I could use this point, that's in between -2 and -3. I don't want to use fractions or decimals. I want to keep it whole numbers. I'd rather use like this point or this point or this point. I'd rather use those points that are whole numbers. So like this, for example, this one right here is -2, -2. That's this point. This B, that coordinate, is 0, -1. And then this point right here, this point would be 2, 0. So I want to use the points with whole numbers. I don't want to use the ones with decimals or fractions in between. Now, all I do is I count the change in y and the change in x. So you just pick any 2 points. So let's just say I'm going to pick, I'm not going to pick B. You could, but let's say I pick these 2 over here. All right? I want to count how much does it go up, and then how much does it go to the right. I want to count that amount. So I draw a triangle. We call it the slope triangle. Okay? The slope triangle. Because you're looking for the slope of this. Remember, this will give us the slope of the line by counting the change in y over the change in x. So let's count it. 1, 2. So that's 2 here. 1, 2, 3, 4. 4. Okay, so my change in y is 2. My change in x is 4. My slope then is 2 over 4. But here's the thing, that fraction can be simplified. So I want to simplify that. If I divide them both by 2, I get 1/2. So now, guys, I'm going to put 1/2 for slope. And my answer will now be y equals 1/2 x minus 1. And there's my answer. Okay, next. What if you don't have a picture? What if they want you to write an equation in slope-intercept form of a line that passes through 5, 4, and -1, 6? Okay, you could draw it. You can draw what we did up there. You know, set up your x-axis and your y-axis and draw it and try to figure it out that way. That is totally a valid way. Or we can use formulas. Okay, so step number 1, we're going to find slope. We're going to find m. Okay. Step number 2 is we're going to then use y equals mx plus b. We're going to plug in numbers that we have for mx plus b. Then once we have that, step number 3, we're going to solve for the y-intercept. We're going to solve for b. So this is the 3 steps to write it without a graph, okay? So step number 1, the slope formula, ladies and gentlemen, to find the change in y over the change in x. There's a formula that you can use, and it looks like this, okay? y2 minus y1 over x2 minus x1. Okay, this is the formula to find slope. So how does it work? Well, you need 2 points, and they give you 2 points. What you're going to do is, in whichever order you want, you have to label these as point number 1 and point number 2. Okay, so I'm going to label this as my point number 1. So this is going to be x1 and y1. Okay, those are my points for x1 and y1 right here. x1, y1. This point over here, this will be my x2 and my y2. Okay, so the way I decided on that is this one was the first one, this was the second one. So I just choose this as my x1 and my y1, this is my x2 and my y2. Now, the y's go on top. So I'm going to take 6, my y2 minus my y1, which is 4. 6 minus 4. Now here, this is my x2, -1, minus my x1, which is 5. Now, be careful. If you plug in a negative for these numbers right here, it could change it. A minus and a minus would change it to a plus. Luckily, we don't have that issue. So now we just subtract. 6 minus 4, that's 2. Oh, wait, that's a negative 1. Negative 1 minus 5. If you're at negative 1 and you subtract 5, you're going to get a smaller number. It's not going to go up. It's going to go down even further. It makes it minus 6. Now again, you never leave this like that. You have to simplify it. So I'm going to divide by 2. So I get a negative slope, negative 1/3. My slope is negative 1/3. Now, Mr. Morales, you put the negative in the middle. Yeah. I don't like to put the negative on the bottom. I like to write it in the middle. Okay? We're not used to doing that. Don't put the negative sign down here. Just put it in the middle. All right? Next. Okay, what's this for? Now that you know slope, we need to find b, but you need to plug in an x and a y. So what we're going to do is let's take this point right here, 4, 5 right here. This, I'm going to use x1 and y1. I'm going to put in the first point they give me. You can plug in the second point if you want, but I'm plugging the first point into the equation. So that means x is going to turn into a 5. So I'm going to put a 5 in here. I'll put a 4 over here. This is what it would look like. 4 equals negative 1/3 times 5 plus b. Okay, so we're gonna we have to solve for b now. So that's where we get to this step. To solve for b, guys, b needs to be by itself, which means we gotta cancel this part out. Now first, we should probably multiply this. So I get 4, if I multiply that, put it over 1, I get negative 5/3 plus b. You know what? I'm going to change this into an improper fraction. So I'm going to change it to negative 1 2/3. So if you're not sure what I did, if you go to Desmos, take 5 divided by 3, and you get 1.66666, or as a fraction, negative 1 2/3. When you're using slope-intercept, you don't want to use decimals. You want to solve it using fractions. Now, if you want the b by itself, we have to cancel out minus 1 2/3 with inverse operations plus 1 2/3. That'll cancel it out, and I'm going to add 1 2/3 over here. But it's a fraction. You're right, but there's also a whole number. So you can add up the whole numbers. What's 1 plus 4? 5. What about the 2/3? Well, that's not going to go away. So your answer is 5 2/3. So now you have the two numbers you need to write your formula. What is the formula for this, or what is the slope-intercept form? Y equals negative 1/3 x plus 5 2/3. There's a formula. All right, last question. So for the last question, guys, what I want you to do is, you see this graph with 2 and 1970 and 4 and 1440. I want you to write an equation in slope-intercept form for this graph using these 2 points. Okay, so you're going to have to find the slope, and you're going to have to find the y-intercept, the starting point, somewhere up here. Now, once you have that, here's what this represents. This is a gift card. So this is the balance after this person buys a medium coffee, Ali. So Ali buys a medium coffee, the card balance goes down. She buys another medium coffee, the card balance goes down. So the question is, how many medium coffees can she buy with this gift card? So you need to know the entire equation to find that information out. All right, so I'm going to put this on Google Classroom. The question will be, how many medium coffees can she buy with this gift card? It'll be on Google Classroom, all right?